In today's video, we are going to begin a new unit. We are going to start looking at quadrilaterals, Unit 8. And so we are going to begin with classifying polygons today and then get into some specifics about quadrilaterals. Okay, so our first section, 1.6, classify polygons. I have a lot of vocabulary to begin with. So I think what I'd like you to do is pause the video so you can write down these definitions. I have some information, like you can see some examples over to the side here, some things here. So go ahead and, if you would pause and write things down and then come back, and I will start explaining over the definitions, and then you can continually pause and resume as needed. Okay, defining a polygon. So the basic definition here is this sentence. It's a closed figure that lies in a plane. So I gave an example of a non-closed figure over here. There's a gap in the opening. Okay, not considered a polygon. We have 3 or more sides, which are considered segments. So this example over here has a curved side. That is not a polygon. Circles are not polygons because they don't have any segments. Another item is that each side is intersecting exactly 2 sides, one at each midpoint. That describes this one right here. So another way to think about this is it can't cross over sides. So like this segment is intersecting right here and right here at the endpoints, but it's also intersecting in the middle. And that can't happen on a polygon. Okay, so the main elements are 3 or more segments. Segments meaning straight, no openings, and no crossing or no intersecting of sides. Okay, convex versus concave. Let me start with concave, and this is, actually, let's start with convex. The formal definition says no line that contains a side has a point in the interior of the polygon. So, for example, if I were to draw a convex polygon, I'll just draw something that looks like this. So when it says no line that contains a side has a point in the interior. So if I were to draw a line over this side, see how it doesn't go through the interior. But if I draw a concave polygon, like this, kind of like the one I drew over there, when I draw over this side, see how the line goes through the inside of the shape. That would be a more formal definition. Informally, I think, well, concave, of course, is just not convex. So I think of the word cave and the word concave. When I look at this shape, to me, this side is caving in. So this is concave. If it's not caving in, like this example over here, it's convex. So the vertices are sort of popping out this direction. Okay, so we will primarily focus on convex shapes. But this first section, I'll have you identify which is which. Okay, equilateral, we've done this word before. All the sides are equal. Equiangular, all the angles are equal. Okay, moving on. So if you want to pause the video, you can. When you're ready, come back and I will talk through these last 2 items. Okay, regular is both equilateral and equiangular. Okay, so if a shape is regular, it has both characteristics. If it only is equilateral but not equiangular, we don't call it regular. Now, it must be convex. Okay, you can't have a concave shape, so a side that caves in, that's regular because the angles won't be equal. Okay, here are some classifications. You probably know up through, I'm sure you know 3, 4, 5, 6, 7, 8, maybe 9, 10. I don't have a good reason why we skip 11. I'm sure you could Google it and find a name. We just tend to not, for whatever reason, have a name for 11. 12 is dodecagon. Now, when we get past 12, we get more general. So like n-gon. So like 15 sides is a 15-gon. A 25-sided shape is a 25-gon. All right. I will want you to know these specifics because you will use these to figure out like angle measures and things like that. So you're going to need to know that like a decagon has 10 sides. Okay, so if you need to pause, make sure you get these words, and then I'm going to move on to the next page and start the examples. Okay, we are deciding whether the figure is a polygon, and then we're going to decide if it's convex or concave. All right, so I see a shape that has segments. That's great. It is closed. Yeah, this is a polygon. Now, convex or concave. So I'm seeing this cave in. So this is concave. Okay, so it's a polygon, it's concave. Okay, I want you to go ahead and do B, C, and D. So pause the video, come back and do check your answers on these three. Okay, the next one is not a polygon. It has a curved side, and if it's not a polygon, it can't be classified as convex or concave. C is also not a polygon. It has got that, line crossing in the middle here, so it's not going to create just a polygon. Last one is good. It is a polygon. It is convex. I do not see it caving in, so it's convex. Okay, now let's classify. Classify the polygon by the number of sides. Tell whether it is equilateral, equiangular, or regular, and then we'll do a brief explanation. Okay, I see 4 sides. A 4-sided shape is a quadrilateral. Now, you might go even more specific. Maybe you wrote rectangle. So that is a type of quadrilateral, but we're going to stay a little bit more basic in this first section. Okay, equilateral, equiangular, or regular. Okay, I see equal angle, so it's equiangular. Sides are not equal, just a set of sides. So that means it is just equiangular. And I guess I'll just talk through the explanation. I kind of just said it a second ago. The sides are not equal. Or actually, let me take that back. It's equiangular because the angles are equal. That's probably a good enough explanation. Okay, next one. I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. This is an octagon. Okay, I do see it's equilateral. I just drew over the sides, and look at the individual arcs on each angle. Okay, these arcs right here. That means these angles are the same. So since it goes all the way around, it is both. So I want to write the word regular. Okay, I don't need to write equiangular and equilateral. So that's my explanation right there. It is both equiangular and equilateral. Okay, last one in this group, 3 sides triangle. Sides, they are not the same, and the angles are not the same, so I'm just going to write none. And so I guess really what I just said is the explanation. The sides are not the same and the angles are not the same. Okay, please move on to example 3. Pause the video until you have your answers written down, and then we're going to move on. All right, this is a quadrilateral, 4 sides. This is regular. I've got equal sides and equiangulars, and that is the definition of regular. Okay, number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is a dodecagon, 12-sided shape. All right, I'm going to erase the blue so we can see that. So I am seeing equal sides. 1, 2, 3, 4, 5, 6. Okay, equal sides. Equal angles. Do we have that too? Now, I have a lot of right angles here, but the problem is all of the angles inside the shape are not right angles. Like, look at the angle stretching from here around. That is not a 90-degree angle. It's there's a right angle out here, but that doesn't impact my reasoning on the polygon, whether it is equiangular or not. So this is only equilateral. Oops, I forgot my I. Hold on. QUI, lateral. So if you look at the first page, we defined under regular that it must be convex. This is a concave polygon. So you are always going to get this angle right here when it caves in, and it will never be the same as one of these interior angles. So all concave polygons, first of all, they're not going to be equiangular, which means they won't be they won't be regular. Okay. All right, one final thing here, and we are just going to solve for x. The directions say each figure is a regular polygon. Expressions are given for two side lengths. Find the value of x. Okay, this word is very important because it's going to tell me how to proceed. So if it's regular, it is equilateral and equiangular. So I'm going to do this. I'm going to do this. So what that means is I now know that these two sides are equal. So let's write an equation and set them equal to each other. Okay, I'm going to start to collect x squareds, excuse me, on both sides. And so see what happens when I go to do this. These add up to 0 and these add up to 0. So now I'm left with 10x minus 19 equals negative 3x plus 85. So that right there eliminated my need to factor because I now have a linear equation here. I'm just going to proceed like I do when I solve linear equations. So you might find in geometry, if you don't already do this, you might be able to move a little faster through your solving. So I'm going to take my x term and move it over here. At the same time, I'm going to take the number without the x and go the other way. So I kind of sometimes do this in one step. So I'm going to add 3x this direction, and then I'll switch colors just to make it more obvious. Then I'm going to add 19 the other direction. Okay, and so when I do that, 10 plus 3 is 13x. These two add up to 0. These two are adding up to 0. And then 85 and 19 is going to give me, that's going to be 4, 8, 9, 10, 104. Okay, now if you don't want to do that, I don't want to push you into something you don't want. If you want to do it in 2 steps, please do that. I think you will find as you progress through your math classes that your algebra gets much, much quicker. You get more precise with it. You get more comfortable with it. And that's the goal because you're going to move past basic algebra topics like solving equations into more complicated ones. Okay, now you're going to divide off your 13, and we are getting 104 divided by 13 is going to give us exactly 8. Okay, so x equals 8. Okay, will you please look at number 5? Pause the video, try 5, and then come back. Okay, again, regular allows me to mark all these. Now, I'm not going to worry about angles because I'm given side lengths. So ultimately, I need to recognize that these guys can be set equal to each other. Oops, not 18, 89. Okay, so if I want to do, when I only have x squared, I can get the variables on one side, numbers on the other. So I'm going to kind of do the same thing. I'm going to add 2x squared to both sides. Since I'm going to the left with the variables, I'm going to go to the right with my numbers. Okay, so again, just do what you're comfortable with. 2 plus 1 is 3. 3x squared. Okay, that adds up to 0. That adds up to 0. 89 and 19 gives me 108. All right, now I need to divide off 3. 108 divided by 3 gives me 36. And then now I'm ready to take the square root of both sides. Now, one area that I pass over a lot is that there's really 2 answers here. So there's really a 6 and a -6 are going to be solutions. Now we throw out the negative a lot in geometry, but this is an example where it won't get thrown out. Okay, so if we come back up here, if I were to substitute in -6 squared, see how when I square -6, it'll turn positive? So when I do that, I'll end up getting a positive answer here. Same thing over here. When I substitute in -6 squared, -6 and -6 is 36. And then when I work through the rest of my problem, I'm going to be able to get a positive answer. So both of these are correct. So you could do this, a lot of times in algebra we write it as plus or minus 6. So just be aware that don't just always toss the negative out. Make sure you're knowing why you're tossing it out, if it can be tossed out. And then if not, then you could potentially have 2 answers. Okay, that wraps up this first section. If you have any questions, let me know.